Here we are. So, in an experiment, question 2, the percentage sand content of soil in a given region was measured at 9 different depths, x centimetres, taken at intervals of 6 centimetres from 0 to 48. This is important. So this thing about x, you know, before anything's happened, they decided that x was going to be every 6 centimetres to 0, from 0 to 48. So x doesn't depend on anything, it's already fixed. The results are summarised below. We've got all the key bits of data that we always need. State with a reason which variable is the independent variable. We've already said this, haven't we? It's got to be x, that's the independent variable. Okay, and our reason is that it didn't depend on the other thing. It was the depths that we were taking this sample were fixed. Or we could say the depths are controlled. Okay? Now it's really important that when answering this kind of question, we put it into context. So we had to make sure we had to say something about the depths, about something that relates it to the question. It's not enough to say x is the independent variable, it's a controlled variable. Okay, because it's got to relate to the situation that we've been given in the question. Part 2. Calculate the product moment correlation coefficient between x and y. So we've got to launch into all those things and actually work them out. They're there on the formula booklet. Which order is it? It's SXX that we start with, isn't it? So going straight to those formulas, SXX is, can we write the numbers down straight away, do you think? It's sigma x squared minus sigma x when you square it over n. So we've got that number there. And actually it's quite a nice big number that we get. We get 2160, I think. I hope so. SYY, again, taking the numbers straight from there. The formula booklet says it's sigma y squared minus sigma y. Where's sigma y? 512.4. When you square it over 9. Just being really careful to get the numbers in there correct. 1422.36. And SXY is sigma xy, so 10674. Minus, now remember this one is you're multiplying these two together, these two, so it's 216 times 512.4, and we're still dividing by n, and that gives us a value of minus 1623.6. Okay? A few things just to kind of check out as we're doing this to make sure that things are going okay. These two will never be negative. These two will always come up with a positive value. Okay? The danger of these two being negative is you end up square rooting a negative number. So these two will always come out positive. This is the one that's going to go on the top of our fraction when we calculate our product moment correlation coefficient. And this is the one that determines whether R is going to be positive or negative. So that's okay that that's negative, but these two we'd expect them to be positive. Put the formula together. R is that one, minus 1623.6, divided by the square root of the product of the other two. And in this case that gives us R as being minus 0.926 for 3 significant figures. So that is a pretty resoundingly strong negative correlation that we've got out of this. That's quite nice to get. Part 3, sorry. Calculate the equation of the appropriate regression line. Well, this relates back to part 1, state with a reason which variable is independent. So the regression line is always one variable on the independent. So if x is the independent one, we're looking for the y on x. Something is based on the independent variable, dependent on independent. So it's y on x is the line that we're after. Which is nice, because y on x is the one that's in the formula booklet, so everything is just going to go to plan. Formula booklet says b is sxy over sxx, and we worked out those numbers and kept them nicely labelled earlier, so that's minus 1623.6 divided by 2160. And I want to try and keep this as accurate as I can, so my calculator's fraction button said that was 451 over 600 minus A. Again, straight from the formula sheet, it says A is y bar minus bx bar. But we've not been told the mean. Easy to work out though, isn't it? Y bar is sigma y over n. So that's 512.4 over 9 minus b times x bar, which is 216 over 9. And if again we put that in the calculator, we get 5623 over 75. I think it's maybe a little bit obsessive for me to keep doing this in fractions, but I'm going to. So again, the formula booklet says the line is y equals a plus bx. A plus b times x. There is our line. And that would be enough. The mark scheme probably allowed these coefficients to 3 significant figures. That's fine. And then it said, now I don't think we actually have to use this for the last bit. The regression line is used to estimate the percentage sand content at depths of 25 and 100 centimetres. Comment on the reliability of each of these estimates. You are not asked to find the estimates. Well, to start with, our product moment correlation coefficient was very close to -1. So we had a strong correlation, so our regression line is reliable. So it's not about how close to a straight line this stuff is. So the regression line is reliable. The first one, 25 centimetres. Well, we've taken readings from 0 to 48. And 25 is bang in the middle of that. So 25 is very reliable. This is part 4. Part 3b. 25 centimetres. That figure would be reliable. R is close to -1. And 25 is inside the range of known values. We're really happy about using 25 as our figure. The second one, 100 centimetres. Well, that first bit, R being close to -1, is now outweighed by the other factor, which is that we're miles away from the data we know about. It's outside the range of known values. We only know about x between 0 and 48, so it's unreliable. If you want to use the good word in here, you could say try and spell it right, and you could say it's extrapolation to emphasise that fact. Right, Done? We did say unreliable, didn't we? Yes. Right. Thanks, Joe.